Hello students, very good evening to you all. Today we are going to study the remaining part of the chapter current electricity or electricity. This is part 2, and in this section we study the resistance and the resistivity. Before this session, we have another session last day. It was there mentioned the Ohm's law and so many things there we have discussed. So once we are going on recapitulation, the things that we discussed earlier was number 1, electric current or current. It was discussed. It is presented by I. Formula was Q upon T, and unit was ampere. It was discussed at that day. I'm again recapping it so that you can, start from the beginning. The second part you have studied at that day was electric potential. When I'm saying about electric potential, this is presented by V, and V is having formula V is equal to W upon Q, and its unit was volt. It is abbreviated as V, and this is abbreviated as E. One more thing we discussed at that day, that was potential difference. Potential difference. This was simply the difference of two potentials. It was presented by delta V. Sometimes this is V written, and same, this unit is volt and abbreviated as V. One more thing we have discussed at that day, and I told you this was, this is very, very important. That was Ohm's law. And according to Ohm's law, V is directly proportional to I, and hence we can write V is equal to I into R. Here R is a constant, and this is termed as resistance. So today we have to define resistance. We have to say what is resistance and why is it coming to a conductor, and what is the unit. I think unit was discussed at that day. R is equal to V upon I. It was fifth one which was discussed at that day. R is equal to V upon I. Unit was volt upon ampere, and that's why this was termed as ohm. And I also stated at the day that its abbreviation is omega. This is abbreviation of ohm. Now we start today's session with the topic resistance. Resistance, we have to define it. At first we define its physical definition, means why is it coming, and then we define its numerical definition. So when we discuss about its physical definition, we can simply say that, let me tell you a story about current flow once again. What happened actually? There are so many electrons in any wire. These electrons are called free electrons. And when you apply or when you connect this wire with the two terminals of battery, one is positive and another is negative. Suppose you are connecting this. So this one will be on higher potential. This one will be on lower potential. So here you can write high potential. Here you can write low potential. So a current will be flown here. We can say that a current will be flown in this direction. But I have told at that day that electrons will move in the opposite direction of the flow of current. So all the electrons will move in this way, opposite to the direction of current. This is the direction of current, and the electron will move opposite to the direction of current. Now, if these electrons will move, these electrons will collide with each other. Suppose that these are the electrons. When they move, they will collide with each other. And due to collision, they will lose the energy. So, energy is lost during collision. And hence, you can say that there is an obstruction in the flow of current. Now, see here, when we define the resistance physically, we can write it here. We can write it here when current flows through a wire. There is an obstruction. There is an obstruction in the way of flow of current. This obstruction is called resistance. So simply, what do you mean by obstruction? Obstruction means, some hindrance, some stoppage, some, in Hindi you can say rukavat. So when we take the flow of current in a wire, you can say current के रास्ते में कुछ रुकावट होती है, and this obstruction, ये जो रुकावट है, that is known as resistance. Resist का वैसे भी मतलब होता है to oppose, to obstruct. So the resistance name is having the same meaning like obstruction in the way of flow of current. Now, we are coming on its numerical definition. when we are coming on its numerical definition, we have to take help of Ohm's law. According to the Ohm's law, V is directly proportional to I, and hence V is equal to I into R. Here you should know what is V, what is I, and what is R. V is voltage, I is current, and R is resistance. So R is equal to V upon I. So simply, what will be the definition here? We can write resistance of a wire is defined as the ratio of potential difference across it and the current flown through it. So this is its numerical definition, and the above one is its physical significance or physical definition. So resistance is defined as the ratio of potential difference across it, वायर के अक्रॉस जो पोटेंशियल डिफरेंस होगा उसका, और करंट जो फ्लो होगा उसका, दोनों का जो रेशियो होगा, दैट इज कॉल्ड resistance. One question is asked from other student, what is resistor? Sir, क्वेश्चन को फिर से समझा दीजिए. Okay, registers, the things which are having resistance is called resistor. Suppose you are taking a wire, तो वायर के पास रेजिस्टेंस होगा, तो आप इस रेजिस्टेंस को रेजिस्टर कहते हैं या कह सकते हैं. सो दुनिया की जितनी भी चीजें हैं सभी रेजिस्टेंस ऑफर करती हैं और सभी की सभी रेजिस्टर्स हैं. All the materials, all the conductors are having resistance, so they are called as resistor. And suppose you are making a circuit. So अभी सर्किट में अगर हमें कुछ जरूरी होता है तो हम मार्केट से लेके आते हैं रजिस्टर, and that register is called carbon register. So it will be learned by you in senior classes. रजिस्टर दो तरह का होता है, एक मेटेलिक रजिस्टर जिसकी बात हम अभी कर रहे हैं, और दूसरा होता है carbon resistor. Resistance, what flow this water? Resistance, yes, if water is flowing in a tube, suppose you should be very clear कि जो electric current होता है, the electric current or electricity is flowing in a wire and the water is flowing in a tube. So there will be the resistance in the wire, and that will be called electrical resistance. There will be a resistance in the tube in case of water, and that will be called hydrostatic or hydrodynamic resistance. So is that clear? Water जब flow होगा किसी tube में तब भी एक resistance आएगा, and that resistance will be known as hydrodynamic resistance. Now, so Are you getting my words? Others? I'm unmuting you. Uh, Others, have you got?
Yes.
Yes, sir.
So you understand all the things?
Yes.
Okay, okay, Victor. Now, we are coming on. One thing that I left at that day was graph. Graph between potential V and current I. When we are saying that according to Ohm's law, V is directly proportional to I, means V is equal to I into R. Here, R is a constant and its name is resistance. Now, if we take an axis, suppose y-axis here and x-axis here, and I'm going to present V on y-axis and I on x-axis. This is x, this is y, and along y-axis I'm presenting the potential difference. Along I am presenting the electric current. The voltage or the potential is in volt and the current is in ampere. Now, when we made a setup at that day, I have told you you can take resistance and put a voltmeter over it, and then an ammeter here, and then a cell or battery you can use, and you can make one arrow so that we can say that this is variable. Of battery, if you are changing, the volt will change, the potential will be changed, and the current will also change. And for that reason, I told at that day that you can make the two column V and I had taken one example. Suppose 3 volt is this one, then 1 ampere current, then this one becomes 6, then this one becomes 2 ampere. When you increase this voltage, not 3, then 6, then 9, the proportionally the current will increase. When you are going to say this is 12, then this one will be 4. So if we plot it here, suppose I'm going to say that this is 0. So you can say that this is 0, 1, 2, 3, 4, and here I'm going to write 3, 6, 9. So when we plot at 0, the current will be 0. If there is no voltage, there will be no current. But when we are having 1 ampere current here, we are having 3 volt potential. And that's why this is presented here with the point, this one. And then 2 and then 6, then 3 and 9. So when we meet these points, we get a line, a straight line. So the graph between V and I will be a straight line. For Ohm's law. So this is, you can say this is Ohm's law graph, or you can say this is V versus I graph, or you can say this is graph between V and I. Now, when we draw a line, it will make some angle with the x-axis. When we plot a line, it will make some angle with x-axis. And when we take tan value of this angle, tan theta, this is called slope. Students, you know about sine theta, cos theta, tan theta?
No, sir.
You have not trigonometry in your mathematics?
No.
There will be some problem, but leave that problem. Think for a while. Slope, suppose you are moving on a road and the road is ascending, means ऊपर को जा रहा है, and then you are descending, कहीं पे road नीचे को जा रहा है. You are getting that कि हाँ ascending और descending क्या होता है सड़क का?
Yeah.
Okay, so when there is descending, road or ascending road, so you can make a horizontal line. You can consider a horizontal line, and your ascending road will make some angle. Okay. Are you getting it?
Yes, sir.
Okay. So the angle will be more, the slope will be more. Clear? अगर ज्यादा एंगल बनेगा तो स्लोप सड़क का ज्यादा होगा, ये तो कॉमन सी चीज है,
Yes, sir.
है ना? ओके, अब उस स्लोप के कंसेप्ट का वी आर गोइंग टू रिलेट विद द ओम्स लॉ. We are saying here that R is equal to V upon I, and this V upon I is equal to slope. It means, what can we say? If we are having Ohm's law graph or VI graph, if we are having a concept of slope, we can say that the slope of the graph is equal to resistance. Clear? If somebody is asking you, what does slope of Ohm's law graph represents, what can you say? You can say that this is resistance. Clear? Okay. Suppose, now this is one question to you all. Kindly respond it. If I'm drawing two lines for VI graph, let me draw this one. This is potential difference. This is current. This is in volt. This is in ampere. Now, if I'm drawing one line for A metal, if I'm drawing second graph for B metal, suppose, then this one is making, suppose 30 degree, and this one is making, suppose 45 degree. So which one will have more slope, 30 degree or 45 degree?
45 degree.
45 degree. And you were saying here that, look at this one, you were saying that the slope will present the resistance. Okay, so which one is having more slope?
B.
B. And if B is having more slope, which one will have more resistance?
B.
B. So this is a very important question asked many a times. You have been given this graph and you will be asked, write the order of resistance A and resistance B. So you can write RB is greater than RA. Clear?
Yes.
Okay.
Yes, sir.
Sometimes, suppose I'm changing this question in this way. I'm not having V here, not having I here. I'm reverting it. I'm saying that I is here, V is here. Now, which one will have more resistance? Now, you have to see the angle from I axis. So this one will be 60 and this one will be 45. So slope is always seen from which axis? I axis. Okay. Now, this is 60 degree. Now, which one will have more resistance in this case? A or B?
A.
A. So clear this one is?
A.
This one is clear?
Yes, sir.
Okay, very good. Now we are coming to the next topic that is called resistivity. When we take the case of resistivity, to understand resistance variation, suppose I am having a wire here and I'm saying that this wire is having resistance and there is the length L of this wire and cross-sectional area A is of wire. Okay. So when we discuss about resistivity, or when we are going to discuss about resistivity, we have to see the resistance of, resistance dependence, we can say, on which factor the resistance will depend. So I'm taking you all back. When I interpret resistance, what I had told, resistance is an obstruction. And why is this obstruction came? Due to collision of the electrons. Okay. Now, if I'm saying you that I have a resistance or resistor and I am going to increase its length, what do you think about collision? The number of collisions will increase or decrease? अगर आप एक वायर का लेंथ बढ़ा देंगे तो इलेक्ट्रॉन ज्यादा टक्कर करेंगे या कम? ज्यादा करेंगे. It will be more. Okay. If collision will be more, what will happen to resistance? Resistance will be more or less?
More.
More. And that's why we can say that the resistance is directly proportional to length. Directly proportional means if one is increasing, another one is increasing, then they will be in directly proportional. Okay. Now, consider this wire as a road, as एक सड़क की तरह मान लीजिए, और सपोज कि आप उस पे जा रहे हैं, पास पास जा रहे हैं, and 2-3 peoples are there and they are getting collide, वो एक दूसरे से टक्कर कर रहे हैं. अगर कोई सड़क की चौड़ाई को बढ़ा देगा तो कोलिजन कम होगा या ज्यादा? If you are having a broader road, then there may be less collision or more collision. Less collision, and that's why
Less collision.
okay, and that's why you can say that R is inversely proportional to A. Inversely proportional means if one is increasing, the other one is decreasing. So resistance depends on length and cross-sectional area. And when we combine these two relations together, we can write it as R is directly proportional to length upon area. Now, you know that due to mathematics, when proportionality changes into equality, we have to put a constant. And here, a special constant is, inserted. That constant is rho. You can say here, rho is a constant. And this constant is called what? Resistance. And one more name is given to you. This is called specific resistance. Okay. So specific resistance or resistivity is introduced in this formula with the concept of dependence of resistance. Now, if we write A upon L, one thing I want to add here, that in the sequence when we are reading resistance first and then resistivity. हम लोग पहले resistance पढ़ रहे हैं और बाद में resistivity पढ़ रहे हैं. But असल में किसी भी resistor के बाद में होता है. Okay, more fundamental property is resistivity, not resistance. Resistivity के कारण resistance पैदा होता है. The resistance is due to resistivity. Now, we are going on definition of resistivity. And its definition will be, numerical definition. I'm going to write resistivity definition. So before going on definition, once again, I'm writing its formula, rho. What is its pronunciation? R-H-O, rho. Rho is equal to R A upon L. I'm going to consider something. Consider A is equal to meter square and L is equal to 1 meter. Then what will happen? Rho is equal to R. So what can be the definition of resistivity? The resistivity of a wire is equal to its resistance. The wire is having 1 meter length and 1 meter square cross-sectional area. So with the formula, we are giving its definition. What is the definition? It is defined as the resistance of a wire of unit length. Unit length means 1 meter length and unit cross-sectional area. This is also called as specific resistance. Why is it specific? Resistance is for all, but you know, some specificity here came. What is the specific things? 1 meter square, 1 meter length. 1 meter square area, 1 meter length is the specific thing, and that's why this is called specific resistance. Now, we are coming on unit of resistivity. When we discuss about unit of resistivity, we have to write formula again. It will be R and A upon L. And I have told you what is the unit of resistance, ohm. What is the unit of area? You know, meter square. What is the unit of length? Meter. 1 of meter square will be cancelled. And what will be the unit? Ohm meter. It can be written as ohm meter. So the unit of resistivity is ohm meter. Now, the most important question of this chapter, which is, you know, frequently asked, is what is the difference between resistance and resistivity? So when we discuss about resistance and resistivity difference, we have to start it from the beginning. Before discussing this topic, difference between resistance and resistivity, I want to add something here. This is not from your curriculum, but you should know. Conductance and conductivity.
ईयरफोन लगा लो.
So when we are having the term conductance, this is presented by G, and G is equal to 1 upon R. Means inverse of the resistance is called conductance, and conductivity is presented by sigma. 1 upon rho is equal to sigma. Okay. One more thing, if I'm taking insulator, suppose insulator, its resistance will be infinity. And if I am taking a conductor, its resistance will be finite. Finite means will have some value. But if we are having superconductor, R will be 0. And you know, the inventions, the experiments are still goes on here. Experiments are on for this topic. The scientists of these days are, you know, trying to get superconductor so that they can supply the electricity or current to the houses without any resistance, without any obstruction. They can save the energy, save electricity. So now we are coming on difference of okay, students, let me have a question from you. Are you getting all the things about resistivity? and specific resistance? If you have any doubt, you can ask.
No, sir.
Okay. Now we are going on the topic difference between resistance and resistivity. You will be surprised that this question is asked in 12th class this year in bold paper. Right, the difference between resistance and resistivity. So this is such an important question. It is important in 10th. It is also important in 12th. So we have to make two columns, resistance and resistivity. So first one will be the definition. I'm not going to write it in detail. You can write it in your notebook on your own. The first one will be definition. And the definition is what? You can write the numerical definition even. What can you write? The ratio of V and I according to Ohm's law is called resistance. Here, according to the formula of resistivity, it is the resistance of a wire of 1 meter length and 1 meter square cross-sectional area. I'm writing in SAR. You can write it, in elaborated way in your notebook. Second one, of unit you can write. Its unit is ohm. Its unit is ohm meter. Third one you can write, it depends on length and cross-sectional area of wire, but rho does not depend. Now, आपको एक क्वेश्चन उठेगा दिमाग में जब आप कंपेयर करेंगे. आपने इसका फार्मूला लिखा R is equal to rho L upon A and R is equal to, rho is equal to R A upon L. Look at this expression. With this expression, I'm saying that this is depending on L and A. But this is also a formula, and I'm saying that this does not depend on A and L, because rho is a basic property. This is the property of metal, basic property of metal. This is internal property. This is not of length and area. So this is one, that if I'm saying you are having a copper wire. So somebody is having 3 meter long wire and somebody is having 10 meter long wire. Copper wire is, in the both cases. So the 3 meter wire will have less resistance and 10 meter wire will have more resistance, whether the resistivity will be same, because the first wire is also made of copper and the second wire is also made of copper. So when the metal is same, the resistivity will be same. So it depends on, but rho does not depend. And on which it depends? It depends on nature of, it depends on nature of metal. And आपको मैं बता दूं कि जो इंडियन सिनेरियो है, इन इंडियन सिनेरियो और in general, the wires are used to send electricity from one place to another place. So जब पहला electrification हुआ इंडिया में, तो it was British days, और Britishers जितने भी थे यहाँ पे, they used the they use the silver wire in those days, because silver wire is having very less resistivity and very good conductivity. And you know about India, what will they do? They did they cut the silver wire and took it to their home, and that's why they changed their concept and they came to copper wire. And still copper wire is being kept. So after that, aluminum wire is used. Still today, aluminum wire is using for transmission of electricity from one place to another place. So now we are going to take some questions from your NCERT textbook. The first question is, let me have. This is the question we are going to solve. See, how much current will an electric bulb draw from a 220 volt source if the resistance, see, the voltage is given to you. If the resistance of bulb is having 1200 ohm resistance, then how much current will be there? So we have to find electric current. We have been given potential difference. We have been given resistance, and that's why in the solution, what can we write? You should write, when you are writing the solution, you have to write at first given that, in CBSE, we have to follow certain way, because the people who correct there, they are very aware of that. So given that V is equal to 220 volt, R is equal to 1200 ohm, and then what to do? Find the value of I. Now we have to write by Ohm's law. You have to write these things. You cannot go with direct formula. By Ohm's law, V is equal to I into R, then I is equal to V upon R, and then putting the value, we are having 220 by 1200, one of 0 will be cancelled, cut with 2, 11 and 60. So it will be 0 point, and then at first 1 ja, and then 8 ja. You can write it as ampere. So this is the first part of the question. Now, what about second part? How much current will an electric heater coil draw from the 220 volt if the resistance of heater coil is 100 ohm? So it is very simple. Same way you can write I is equal to V upon R, and for the next problem it will be 220 divided by 100, it will be 2.2 ohm. So this will be part B. Now, if we are, suppose the question is, the potential difference between the terminals of an electric heater is 60 volt. It draws a current 4 ampere from the source. what current will heater draw if the potential difference is increased to 120 volt? So here what the things are given to you. See, you have been given here the potential difference between the terminals of electric heater. So firstly, V is known to you and I is known to you. So you can calculate with these two information the R of the electric heater. You can calculate. Now, if potential difference will be 120 volt and R you have calculated, nu I you can calculate. So see here in the first case, or when we are going to solve it, solution, what can we do? If V is equal to 60 volt and I is equal to 4 ampere, then by Ohm's law, V is equal to I into R, and hence R is equal to V upon I, that is equal to 60 divided by 4 is equal to 15 ohm. And this one will be the resistance of what? Electric heater. So now you are having the information of resistance of electric heater. So if the same electric heater is used, but now the potential difference is becoming 120 volt. So for the new case, now if V is equal to 120 volt and the R will be same. So R will be 15 ohm, then what will be the I? So I will be equal to V upon R is equal to 120 divided by 15, and 15 is 120. So 8 ampere. This is your answer. Now, one question on resistivity we are going to have. Suppose here the resistance of a metal wire of 1 meter length is 26 ohm at 20 degrees Celsius. If its diameter is 0.3 millimeter, what will be the resistivity of the metal at that temperature? Use the table. I'll show the table just after this problem, and then you can decide which kind of material it is. So see here, the things which are given are, what the things are given. Resistance is 26 ohm. Clear? Now, its length is known to you, 1 meter. And diameter of the wire is known to you. And that is given in, diameter of the wire is given in millimeter. So this is diameter. Diameter is 0.3 mm, millimeter. And milli means 10 raised to power minus 3 meter. So what will be the radius here? Radius will be half of the diameter, and that is 0.3 divided by 2 into 10 raised to power minus 3 meter. That is 0.15 into 10 raised to power minus 3 meter. Okay. Now we have to find the resistivity. So these are, given that. Now, when we are going on solution, what can we do? We have to write the formula of rho. Rho is equal to R A upon L. See here, metal wire, any wire, you know, generally the wires are of this shape and their cross section will be circular. And this cross section's radius is known to you. So what can you write here? R, which is known to you, that is 26. Area is equal to pi r square. Pi r, and r means how much? 0.15 into 10 raised to power minus 3 whole square divided by how much? L. L means 1 meter. So this is 26 into 3.14, pi is value, and then we can write 0.15
Yes, ma'am.
into 0.15
Yes, ma'am.
into 10 raised to power minus 6. And now if you multiply,
Yes,
you
ma'am.
can
I
get
have it.
the value. 26 into 3.14
I too don't know.
into 225 into 10 raised to power minus 2 here, and then minus 6. So how much? Minus 10. Now when you
Yes, ma'am.
multiply,
Thank you, ma'am.
you will get the answer. And what will be the unit of this one? Ohm
Meter.
meter. Okay. So this is all about your
Resistance and
resistance,
resistivity.
resistivity. One question. This question, can be taken as a formula. If I am, suppose I'm writing here the question. If a wire is stretched twice, what will happen to its resistance?
Resistance double हो जाएगी.
Let us see. Okay, डबल नहीं होगी क्योंकि आपने जब सपोज इफ यू आर डूइंग डबल ऑफ द लेंथ तो उसका क्रॉस सेक्शनल एरिया पे भी तो असर पड़ेगा ना. आप अगर किसी वायर को खींचेंगे तो वायर लंबा होगा तो उसका जो एरिया होगा वो कम भी तो होगा. See, if I'm taking this one in this way एंड मैं आपको बोल रहा हूं कि आप इसको खींच के स्ट्रेच करके इसकी लेंथ, मैंने इसीलिए स्ट्रेच बोला. आई एम नॉट सेइंग यू दैट द लेंथ बिकम्स ट्वाइस. आई एम सेइंग यू दैट stretch it and make its length twice. Okay, and that's why you can say here its length is 2L now. So see what is happening to the new area. Suppose new area is A dash and new length is 2L. So what will be the volume here? Volume is equal to area into length. Here the same material is there and that's why same volume will be here. So we can write AL is equal to A dash into 2L, and that's why LL cancel. A dash is equal to A by 2. So area becomes half when you increase the length twice. Now इसके resistance को हम लिखते हैं R1 is equal to rho L upon A. Rho is the resistivity of the material. Since the material is same, मैंने यही वाला wire extend किया, that's why rho will be same. Now I'm coming to this section. R2 is equal to rho, which will be same. Now the length becomes 2L and the area becomes how much? A by 2. And this 2 will go up, and that's why this will be 4 rho L upon A. So what happened? R1 is equal to rho A upon L, and we can place it here. So new resistance is equal to 4 times of the resistance. So you can make it one rule. If somebody is saying you that you are stretching a wire up to thrice of of its length, then its new resistance will be 9, 3 square. If somebody is saying 4 times, then 16 times the resistance will be increased. Okay. So that is all for today's topic. आपको अगर कोई सवाल हो आप पूछें. If you are having any doubt, I'm unmuting you all. If you are having doubt, you can ask. No doubt? Any doubt you have? Let me start it from the first slide. Recapitulation, then resistance and resistivity definitions. This graph should be very clear to you. Now, graph problems, resistivity definition, difference between resistance and resistivity, and the numerical problems. Now you can solve the numerical problems from NCERT, and if you are having any other reference book, you can go from there. You can take the questions from there and you can solve it. And you can have the problems from our S2S app also. If you are having, you can go there. There will be the problem set. You can download it in PDF form and you can solve it. Okay. So that's all for today's class. Thank you and goodbye.
Thank you, sir.